Okay, in a typical reaction mechanism, we have four main. The four are substitution, addition, elimination, and rearrangement. So, first let's get into substitution. Okay, what is substitution? There are two types, SN1 and SN2. The SN stands for nucleophilic substitution. They are reactions. SN1 has a two-step reaction where it only has one substrate involved in the rate-limiting step. SN2 reactions has two substances involved and it's just one step. The first step of an SN1 reaction is the bond that breaks horizontally between an example. Let's say, where did I put the example? Here. I didn't do this right, so my apologies. Here we have a Y and a Z. This Z wants the Y. It wants the space of the Y. This then substitutes the Y, this here molecule substitutes the Y for the Z, leaving just the Y out. So the halogen, which one's the halogen? I think it's Z. No, it's Y. The halogen Y leaves the halogenoalkane, which is this bit, as a Z ion forms. This forms a tertiary carbocation. If the halogen X breaks homolytically from Y, it leaves A to Y radical, leaving two free radicals here. In the second step of a tertiary carbocation is attacked by the nucleophile. The nucleophile is where a pair of electrons are donated to a partially charged atom. For example, 2-bromo-2-methylpropane is a tertiary halogenoalkane. When a nucleophile such as hydroxide, it immediately joins on the carbocation. Because bromine has taken its 2 electrons with it leaving the positively charged carbon in the middle, this then makes it a tertiary carbocation. That's 2-methyl-2-propanol. But I've done an example elsewhere, should be found in my assignment. The SN2 reaction, the 2 stands for biomolecular, as the 2 substrates. In the mechanism involves the nucleophile attacking the carbon atom from behind. The rate determining step is dependent on the concentration of the nucleophile as well as the concentration of the carbon substrate. The nucleophile attacks the substrate when it's at a 180-degree angle. This then forms the carbonucleophile bond and the carbon group bond is broken. This is broken for a transition state. The brackets. So I'll give an example. Transition state. Okay, now we go on to addition. Addition here is where a molecule is built like this. It has a C double bond to another C, a carbon bond with 2 R's connected to them, but it has 3 electrons. Meaning if these two want to pair up this, it will remove the double bond of the carbon atom and making a double bond between A and B for the carbons. So it will make a double bond for AC and then BC, leaving the R's to move adjustantly to the top, giving this. Wait, I'll just remove that, it's fine. There can't be 2 A's if there's not. two A's in the reaction. It will be AB. Okay, so with elimination, so it's my fault for not doing it right. Elimination is here. So we have a molecule like from before. This one, same molecule. It goes through a state where it doesn't want these any longer, the A and the B. Oh wait, no, that should be a double bond, right? So it would break the bonds between A and B, leaving it back to its original state from the addition that I used for an example, and it would leave out A and B, A bond to a B. This is what would be created. So this is elimination. It eliminated the A and the B bonds. With rearrangement here is where a molecule wants to rearrange its atoms elsewhere. So if this carbon doesn't want this atom, it would want an R group because it doesn't feel like it needs it, but this doesn't feel like it needs it. So let's say this has two ions, negative, and this is partially positive. No, this is partially positive. This is just normal. This has only one ion here, one ion here. It connects to this. Let's say this one has one ion here. This is complete with more electrons. 2, 4. This only has 3. So it replacing that with a 2 with a 1 will give this 1 and give this one a 4. So this would have 4. This is rearrangement. So C bond to C to an R has been changed, has been flipped. This has been flipped. And this is what's left. That's elimination, addition and elimination. It added this A, it eliminated the A, replaced it with the R, added it, and then added it to here again.